We're going to continue today. Really, the topic is solving systems with substitution. That's what we started on Friday. But how we're going to finish off the lesson is, again, revisiting these application problems, right? And we're just going to do a little bit each day, and we're going to use whatever method we're using that day to solve, okay? So here's an example. We're going to go through a couple of examples together, and then you should hopefully have a good chunk of time to work on homework as well, okay? All right, so create a linear system to model this situation. Nuri invested $2,000, part at an annual interest rate of 8%, and the rest at an annual interest rate of 10%. After 1 year, the total interest was $190. Solve this problem. How much did Nuri invest at each rate? Okay, so this problem, I think some of you actually were starting to work on it and got a little stuck. This is a really good example of a problem where there's only so many ways that we can ask these types of questions. And this is an investment problem. And if you've seen an investment problem, you probably know how to do investment problems. If you haven't seen it before, you may have some trouble getting started, but we're going to talk about it together, okay? So we did talk overall, though, about how do we start to set these things up last class. And the first thing that I suggested was define your variables. What are the two unknowns here? And one thing that you can look at is the very end of the question. How much money did Nuri invest at each rate? I think it would be helpful if I put the pen on. Hold on, wait, I want to move this back. All right. Okay, so how much did she invest? This is not being very kind to me today. Come on. Okay, hold on. Let me just do this. I'm going to quit. And restart. I wish that I could just have an on-off switch. And then when I'm not doing very well one day, I just turn myself off for a while. See if that helps. Works really well with technology. Okay. While this is setting up, let's actually talk about this. This is an investment problem. She's investing $2,000 in two different investments, right? One's at 8%, one's at 10%. Well, why would she do that? Why wouldn't she just invest it all at 10%? Because this actually happens a lot in real life. People invest in different amounts, different investments, all at different interest rates. Yeah. Exactly, yeah. So that the idea is diversification, right? So if you invest in a lot of different companies and on average they all do well, then if one of them tanks, you're probably still going to be okay, right? Whereas if you put all of your eggs in one basket and that company tanks, then you've lost everything, right? And that's basically, I don't know if you guys have ever heard of a mutual fund. Yeah? Do you guys know what they are? No, so mutual fund is basically a collection of investments in companies that a bank puts together where people can invest in that collection of companies instead of just one, right? And certain mutual funds are more risky than others, but overall, they're usually pretty secure. Typically, the higher the interest rate, the more volatile that particular investment is, meaning that it can go really high, but it can also go really low, right? So when you go and invest money, that financial advisor might ask you about your level of risk. How comfortable are you with some risk? They might ask you how long-term the investment is, because Sometimes if you put your money in an investment where you can't take it out for a long period of time, your return, which is the amount of interest you get, is actually higher. But then, of course, if you need the cash right away, you have to pay a penalty, right? That's the idea of an RESP. No, not an RESP. Well, actually an RESP as well. RRSP and an RESP. An RESP is a registered education savings plan, right? RRSP is registered retirement savings plan. I think the first word is registered. Don't quote me on that. But the idea is like if you put money into an RRSP, right, you only actually get to take that out when you're 65 years old. If you take it out before, you have to pay tax on it, which is usually quite expensive, right? But those investments are typically more secure. And typically, those investments will also be in a whole variety of companies as opposed to just one. All right, where are we? Here we are. Okay, let's hopefully this will work. So she's investing in 2 companies. One of them has an interest rate of 10%, and one of them has an interest rate of 8%. And we're being asked how much did she invest at each rate? Okay, so what do you think are the 2 unknowns? Yeah.
The investment in the 8%, the investment in the 10%.
Yeah, how much she invested at 8% and how much she invested at 10%. Right? Maybe she split it 50-50, where 1,000 to 1,000. Maybe it's 100, 1,900, right? But that's the unknown, right? How much did she invest at 8% and how much did she invest at 10%? So let amount invested at 8% be X, or whatever variable you want. Let the amount invested at 10% be Y. Okay, so that's like our first step. Okay, in our second step, we want to try and use the information in the problem to build 2 equations, right? If we have 2 unknowns and 2 equations, we can usually solve that system, okay? So let's see if there's any totals in the problem, because that's one thing I told you to look out for last class. Yeah?
2,190.
Okay, 2,190. What is the 2,000 the total of? Yeah?
It's the total amount of money that can be invested.
Yeah. So total amount invested is $2,000. Okay? Well, if she invests X at 8% and Y at 10%, what's an expression for the total amount invested? Yeah?
Is it X plus Y
Yeah.
equals 2,000?
X plus Y is the total amount invested. So X plus Y would equal 2,000. Okay? Now, the total interest was 190. Okay, or actually, I was going to ask you guys that, but I just said it. Oh, shoot. Okay. Yeah, so the 190 represents the total interest. Okay, so let's break that down. A little bit, okay? Now, if she invests X amount at 8%, right? Let's say she invests $100 in the 8% investment. How much interest is she going to get from that? Yeah, $8, right? So that is actually not the full amount that she invests. That would be an incredible investment, but it's 8% of that amount. It's 8% of 100 is the amount of interest that she'll get, right? Well, she didn't invest necessarily $100. She invested X amount. So the interest that she's going to get from X is 8% of X. And the interest she's going to get from Y is 10% of Y. And that is what equals $190. Okay, now we're almost there, but we need, this is sort of quite wordy, less wordy. We need this to be a mathematical statement at the end of the day. Yeah?
Would you convert it to 0.08
Yeah.
of x and then 0.1 y?
Exactly. So 8% of, when you're doing a percent of question, of means multiplication. And the percent has to be in decimal form. So this is 0.08x plus 0.1 or 0.10y equals 190. Okay? And now this equation and this equation will make up our system. So this is step 2, getting those two equations down. Okay? In step 3, we have to solve this system. And today, because we're looking at substitution, we're going to use substitution to solve. Okay? All right, so in substitution, what do we do first? Yes?
We have to isolate one variable in one equation.
Right, isolate one variable from one equation. So which equation, by the way, would you choose? The first one or the second one? Yeah. First one, because it's like x plus y, right? So it's pretty easy there to either isolate x or y. I'm going to just, I guess, isolate x because I wrote it first. So if I subtract y from both sides, I would have x equals 2,000 minus y. So that's the first thing, right, in substitution. The second thing, and some people were getting a little bit tripped up with this step, you have to sub into the other equation. So if you're getting a little bit, if you're a little shaky on this step, what I would recommend doing is you isolate it here, write out the other equation. So the other equation is 0.08x plus 0.1y equals 190. And look at what the variable is that you isolated, right? So here we isolated x. What I'm going to do is I'm going to rewrite this equation, but instead of an x, I'm going to put brackets. And make them like relatively big, because we have to fit that in there. Right? And in here I'm going to put this, 2,000 minus y. Okay? And now we have to just solve it. So this is step 2. Now we have to solve. So we're going to distribute, collect like terms, all of that jazz. Okay? So I believe this is 8% of 2,000. 8% of 1,000 is 80. So this is 160, I think. You can use a calculator for that, though. 160. And then minus 0.08y plus 0.1y equals 190. Right? And then maybe I'll subtract 160 from both sides. Do 2 steps in one here. So this side is 30. On this side, this is like 10% minus 8%, right? So that's 2%, 0.02y. But again, if you are getting a little bit, if you feel a little shaky on doing this addition subtraction, just add or subtract the coefficients on your calculator, okay? And then, of course, we need to divide by 0.02. And that is 30 divided by 2 is 15. Is that 1,500? I think so. Can someone check that? I think that is. Okay, so if x is 1,500, what's y? Sorry, if y is 1,500, what's x? How much was invested? Yeah, 2,000 invested, so x is 500. So you would also, by the way, want to say this is the 10% investment, and this is the 8% investment when you are fully answering the question, right? Relate the variables back to the let statement. Connect at step 4. This is the 4th step where we get y, or sorry, we get the other variable. We get x in this case. Just go back to the let statement and see what did these variables represent. Okay. All right, questions there so far? All right. So we're going to do a couple more, and then that'll sort of be it for today. Okay, so a community group purchased 72 cedar trees and spruce trees seedlings to plant for an Earth Day project. I can't seem to read today. All right, the number of cedar trees was twice the number of spruce trees. How many of each tree seedling did the group purchase? Okay, so what are the unknowns here? Yeah.
How many of each tree was?
Yeah. How many spruce and how many cedar, right? So in step 1, let the number of spruce seedlings be S. Okay, and let the number of, what's the other kind? Cedar. Seedlings be C. Okay, so that's our first step. In our second step, we need to try and come up with 2 equations that relate these 2 variables to one another. Okay, so first look out for any totals. Do we have any in this problem? Yeah, 72. And 72 is the total of what? Yeah. Not cedar trees necessarily yet. All of them, right? So 72 is all the trees added up. So that would be S plus C. Total seedlings equals, what was it? 72. So that's S plus C equals 72. Okay, and then the number of cedar trees was twice the number of spruce trees. Yeah.
Would it be 2s equals c?
2s equals c. Yes, it is. How do you know? So a lot of people, by the way, have trouble with where the 2 should go, right? So you have s and you have c, and you know one of them has to be doubled to equal the other. Do you know what I mean? Okay, so a lot of people say number of cedar is twice, so they put a 2 here. When in fact, we actually have to double this one. And what I always tell people, if you feel like you're guessing, okay, then suppose the spruce tree, let's say there are 3 spruce trees, okay? How many cedar trees would there be then? 6. What do you have to double to make them equal to one another? The 3, right? And that trick usually works every single time, because sometimes the word twice or half or 3 times or something like that is closer to the variable where you actually have to double the other one or triple the other one or half the other one kind of thing. Okay, so I always tell people, if you're unsure, just do this sort of thing. What would you have to double to make them equal? And the easiest way to figure that out is just to plug in a number and work with an actual number. Yeah, so this has to be a 2. Okay, so that is our other variable, or not our other variable, sorry, our other equation. Okay, now, if we're going to solve this, first step in solving is to isolate a variable. Well, look at our 2 equations. Do we have to do step 1? No, how come? Yeah, C is already isolated. So listen, you could go and still isolate another variable if you want, but since C is already isolated in the second equation, I'm going to replace it in the first equation. Okay, so this is sort of in my solving, I already have that c equals 2s. So I'm going to write down the other equation and then replace the c, right? So this will go here. And then we end up with 3s equals 72. And so when we divide by 3, s is 18, I believe. Okay. Well, if s is 18, what's c? Yep.
I think it's 24. It's 24.
You're right. It is. That's 72 divided by 4, not by 3. There we go. Okay, thank you. All right, so if s is 24, then what is c? 48, yeah, right? Okay, so there's 24 spruce seedlings. And 48 cedar. Seedlings. Okay, questions with that? All right, so we're going to do one more, and then we'll stop for today. Here's our last one. The perimeter of a Nunavut flag is 16 feet. Its length is 2 feet longer than its width. What are the dimensions of the flag? What are the dimensions of the flag? Okay, so what do we want to know here? What are our two unknowns? Yeah. The length and the width of the flag. Now, I wanted to talk about this example because what I often do when I'm working with a system and the unknowns represent dimensions of a shape or something like that, is that I actually do my let statement in the form of a picture, right? So in step 1, instead of actually saying let length be L and let W be width or whatever, I will do this. Because then just having that visual there helps me with the second step, which is to come up with some equations, right? And defining your variables just basically means someone can look at it and know what the variables represent. That's perfectly fine to do as a picture, okay? You could if you want, right? Let length be L and let width be W if you want, but up to you, okay? Now, in step 2, we need to come up with 2 equations that connect these 2 variables, okay? So what information have we not used yet in this picture? Yeah. Perimeter. The perimeter is 16. And what if we have the width and the length, what would be an expression for perimeter? Yeah.
2L plus 2W.
Yeah. Exactly. And I find that having the picture there really lets me see that, right? Because of course this is also W and this is also L. So 2L plus 2W is 16. And then do we have another piece of information that we can use? Yeah.
That its length is 2 foot longer than its width.
Yeah, the length is 2 feet longer than the width. So 2 feet longer than the width. 2 feet more. How do we translate that into a math statement? Yeah.
It would be W plus 2 equals L.
Yeah, the length is 2 more than the width. So the length is 2 more than the width. Width plus 2. We're adding an extra 2 feet onto the width. Okay. Now we can solve the system. Okay. Now again, we have to isolate a variable. So what would you do there? You've got these two equations, and in substitution, the first step is to isolate a variable. Yeah.
L, because it's already isolated.
L is already isolated, yes, so you can just use that. If you want to do something else, that's fine, but you can just use this, and then that step is sort of done, right? So L equals 2W. So I isolated in the second, I'm going to sub into the first. So I'll write this out. No, W plus 2, there, that's better, right? And I isolated L, so that's where I'm going to put my brackets in for L. Okay, and in the brackets, I put the expression that I isolated, so W plus 2. And then I have to just, do the normal distribution, collecting like terms. Okay, and then you can solve minus 4. So this ends up being 4W equals 16 minus 4 is 12. And then divide by 4. The width is 3 feet. Okay, what's the length? 5, right, because it's 2 more. Okay, now one thing that I do want to mention is I would bet money that a lot of you guys could just figure this out in your head, this particular question. Because the numbers are fairly small. You could do some trial and error and work with the constraints in the question to figure out, yeah, the width has to be 3 and the length has to be 5. Okay? So what I want to get at is I want to make sure that when you are doing a question, when you're practicing, and also on an assessment, that you just read the instructions carefully. Because if you are asked to solve the problem using a specific method, and you use guess and test, you will definitely lose marks and could get 0 on that question. Okay, so if I said, and I could give lots of instructions. I could say, if I just say solve, you could do whatever you want. So you could solve graphically, you can use substitution, you can use elimination, which we're going to talk about tomorrow, or you could try and use guess and test. If I say solve graphically, you have to solve graphically. If I say solve using substitution, you got to use substitution. If I use elimination, you got to use elimination. If I say solve algebraically, you have a choice of either substitution or elimination. Okay, but please pay close attention to that. There's a couple of reasons for that. The most important one is that when I am assessing where you're at, and this is a particular skill that you need to know in the curriculum, then I am asking you to demonstrate that skill. Yep.
Do you think that one, like graphically or algebraically, should be asked more than the other?
No, I would say that they're about even. The other point that I wanted to get at, though, is that just gearing up, I know it seems really early to think about this, but it's good to put practices in place. On diploma exams, on the written response part, you will get 0 if you don't use the method that is asked for, and they are quite specific. Okay, so it's kind of like you don't usually make that mistake more than once. So if you make it on one assessment in grade 10, then hopefully by the time you get to grade 12, you'll be able to pay more attention to those kinds of details. No, I would say that you're going to be asked the 3 methods fairly equally. One thing I will say, and we'll talk more about this on Thursday, is that when I am solving a system, I typically take a moment to look at the system first and think, what method is going to be most efficient when I'm solving this system? And I personally probably solve 80 to 90% of systems using elimination, which we're going to learn tomorrow. Okay. There are instances when I solve graphically, and there are instances when I solve using substitution. This actually would probably be a good one, because when I look at this, I'm like, oh, one variable's already isolated. That makes substitution pretty easy. I'm just gonna use substitution, right? And you get a little better at that the more practice you do. When you guys do elimination, you'll be like, oh my gosh, that's so easy. Let's just do this all the time. And so that's usually the feedback that I get. Substitution is important though, because as you move into grade 11 and grade 12, you're also going to talk about solving systems that are not linear. So you might look at something with an x squared in it, or an x cubed, or something like that, right? And when you do that, substitution is often the only method that is available. So you have to have the idea around isolate a variable, sub it into the other equation. Okay? Questions so far? Okay, so I am going to wrap up. You guys, there's a couple of problems that you can work on this page, and then you can spend the rest of class completing homework. Yeah.
I was just wondering, on my IPP, it says that I'm allowed to listen to music, but they blocked Spotify on the school
Oh,
Wi-Fi,
yeah.
so I don't know how to get around that.
I don't know either. Can you download some stuff?
I don't have premium.
Oh, you don't? Okay. Maybe like listen to music on YouTube, or I don't know. I don't know. Yeah. To be honest, like, I'm not the